Welcome to a new episode of the Energy Bridge. Today we have the pleasure to have Lukas Höber, if I pronounce it well.
Yeah, that's fine.
Yeah. Well, since I'm from Chile, from a mining country, I'm very excited to this interview because you are a metallurgical expert, an entrepreneur, and working with CO2. So it's a lot of topics together, very interesting. So thank you for being here with us.
Thank you very much. Yes.
Thank you very much, Lucas. You're one of the coolest researcher. I already told you.
I'm not a researcher anymore.
But having said that, yeah, you have a way, like you have done so much, man. I have 3 pages of what you have done already. How old are you?
I will turn 32 soon. Yeah.
Interesting.
Yeah, maybe we could start with your educational journey. And you were telling us behind camera that Austria is, you only have a small mining. So how did you get this metallurgical passion?
Yeah, passion. So I grew up in a small town. It's close to Leoben, where I studied. Leoben has, or still has, but back then it had a very, very high reputation in terms of engineering. So it was always considered a very good technical university, and still is.
Mm-hmm.
Just in the last years got a big down because the urge to study something in engineering got much less in Austria. Less and less people are studying engineering, and so also it hit hard on Leoben. Every first year at this university is the same for every major. And then they make these presentations of the different studies and they present themselves to all the students. It just looked very interesting, you know, like metallurgy is very big, very hot. Everything is super heavy. In a steel plant, everything can, you know, just the crane that picks up steel blocks has 5 tons just at the very top of the crane. Everything is massive. I just liked it, and back then I also was interested in earning money. I would say I have to say back then I was like, I want to have a job where I can earn, have a nice career as an engineer, and metallurgy for sure is a field where you can do that. So then I started. After 1 year I switched and started metallurgical engineering, and then I just stick to it, and I always liked it. I have to say it's very niche.
Mm-hmm.
I've never in my whole life met anyone outside of a professional context that also studied metallurgical engineering. At conferences, yes, of course, but no, not at a single party, never. I met anyone who was like, I also studied metallurgical engineering.
In India, when you go for engineering,
Yeah.
So if you have a higher rank, you go for computer science.
Yeah.
If you have slightly lower rank, you go for electronics and communication.
Mm-hmm.
Then a bit more, then maybe mechanical, and if you have the last rank, then
Mining and metallurgy,
or mining or metallurgy or something. But I mean, it's getting more and more important now. Like you can, I'm talking about way back, like a decade back.
Yeah. In Austria has a very strong metallurgical industry.
Yeah.
You know, there's this process. If you produce steel, you take iron ore, take out the carbon, then you have enriched hot metal with enriched carbon content, and you need to take out the carbon. And this process, you blow in oxygen. This process is called basic oxygen furnace, or LD process. It's the most famous industrial process in the world, and around 75% of all steel is produced by this process. It was developed in Austria, called LD is Linz-Donawitz process. Mm-hmm. So we have a very strong metallurgical background. Yeah. And I just, like that, I stick to it. And that's how it...
You did all your studies in Leoben?
Yeah. Everything. I told you I was in India for 2 months as an internship. And then during my PhD, I wanted to go abroad, but then Corona hit. So I was 8 years in Leoben, yeah.
Yeah, and in the middle of your studies, you went into recycling technologies. How was that motivation, and what did you do?
I have to say, heavy industries, everything in heavy industries moved into sustainability, you know. It's all energy optimization, less resources, recycling. So when I looked at potential master thesis topics, it's all recycling optimization. So I just started a master thesis in recycling engineering. recycling some slag. Slag is a byproduct in every pyrometallurgical process. So it's every mineral material that was liquid at some time is a slag. So I started in this field. Then I liked it pretty much, this whole heavy industrial sustainability topic. It just seemed very interesting and challenging to me. And it is very challenging. We can talk about it later. For a long time, it is never ending and very challenging. And this is how I got into this field. Actually, also when I was in India, it also did something to me to see the environmental problems, of like Mumbai. And I was just like, what can you do?
It worked, right? Like going to India and it changed your life.
It changed my life, yes, in some way for sure. Yeah. Now I came back, then I graduated.
Okay.
Then I did 7 months of traveling. And then I went to India again in this traveling period, and then I traveled the whole country and also other countries in Southeast Asia. And I was like, well, yeah, you need to do something, I'm a big Africa fan also. I've been many times in Africa, and it's the same thing. In Africa, who is developing a recycling process if you are in a country that has much bigger urgent problems, Yeah. So I always was like, we should develop technologies for the world in a country where we can do it. And this is why I then stuck to recycling engineering and did my PhD in this field. And I always liked it. I really have to say it was a good profession to choose.
But it's also a thing, like everything that got manufactured.
Yeah.
In poorer Asian countries and African, they got stuck with it. Like plastic is a big problem in India and also in Africa.
Yeah.
100 years ago, everything was sustainable for them. They would use plant-based plates or steel plates. Then plastic got introduced, I guess, 30 years ago or something, and now there's filth everywhere.
Yeah, it's crazy. It gets ever more crazy. No, so this was how I maneuvered into this field.
Did it also inspire you to take on entrepreneurship?
I think I always had this entrepreneurial thing in me. I just for a long time didn't do much about it. But looking back, I've always been like this. I think my studies were too consuming. So that was not really a possibility. I studied like crazy. I wanted to get done with studying, and there was not much to do around that. But then I started working in my PhD, and I worked, and after 40 hours, everyone went home, and I was like, I was always, and also still today, I don't know, but I have too much energy, I have just, it can be annoying also to other people. I can't go home after 40 hours. I don't know what to do then, I do a lot of sports and stuff like this, but also back then, everyone went home at 3 o'clock, and I was like, I can't do this. I can't do this for 3 years, I will go crazy. And then I founded these 2 NGOs, and it really gave me a lot of purpose. It was also like building something entrepreneurial on a voluntary basis. But I worked 40 hours a week and then put in another 25, 30 into building those 2 organizations. And
what are they about?
So the first one doesn't exist anymore. It was called Engineers for a Sustainable Future. So I wanted to, seeing all this crazy environmental pollution in other countries, I was like, we need to leverage engineers. So what I realized in Leoben, a lot of the studies went into sustainability, but on an engineering field, like energy optimization. I studied metallurgy, and I never had any lecture about sustainability, nothing at all. And I was like, this is weird, There's a study, it's called environmental protection. They had some stuff, but we in metallurgy, nothing. And I was like, we need to, we cannot transform sustainability-minded people to become engineers. It's impossible. If someone who's very idealistic is like, we need to change this and that, they don't change the blast furnace process, Like people who worked for 20 years in blast furnace research might change it, but it's rocket science to change something there. You can't just maneuver in there and be like, I will now build a new blast furnace. So I was like, we need to change the engineers of the future. So how we could do this? Let's organize some events and speeches and presentations of people who can tell them nice stuff. And that's what we did. We invited some people. And then a lot of people came to us and were like, I also want to be part of this organization. We're like, there's nothing to do. I mean, we're 3 people. We're organizing events. We don't need 16 people for doing that. And then we came up with this idea of starting a think tank. It's called Shift Tanks.
Yeah.
It still exists, but I exited it September. It's already 3 years. So we founded it 5 years ago. If you are a company and you have a problem which needs to be solved, but not just for you, you can hand it in there. And students in engineering, and I have a lot of PhD students also, and more senior people work on it completely for free and voluntarily. And this is what Shift Tanks is doing. And this consumed a lot of my time because we, running this thing with, over 100 people at some point, it was crazy, but it was also fun. And it got a lot of nice feedback. We got this Austrian Sustainability Award for student organizations handed over by Leonore Gewessler, 3 years ago. This was my start in entrepreneurship, and
So now maybe we can go to the point that brings us today, which is your company Sequestra, that you are the founder. So maybe you can tell us, what did you see in the industry that you decided to go for it?
We talked about this beforehand, If you talk about people in the sustainability bubble, I call it, because right now it's a shrinking bubble again, unfortunately. It was very big a few years ago, and I got a bit bubblier. You hear a lot that people say, we have all the technologies, we just need to implement them. Then this is very true for energy generation, like PV, Of course you can implement it, but this is not true for heavy industrial production. Right now, if you want to produce any metal in a green way, good luck. There's no metal in the world which is produced green. Unfortunately, we are far off. And the reason is that it's much more complex than just changing the overall production process. It's so interconnected, everything. And I was like, I would like to be involved in something technologically challenging. And already when I did my PhD, I recycled wastes from heavy industry. So my PhD was on recycling sludge from the zinc industry. And if you recycle any metal, I'm not talking about just melting a can and producing, or melting a copper coin and producing a new copper coin. This is very easy. But if you recycle a smartphone, you can get out some of the metals that are in there, but you will end up at some point with a residue that's much more complex to recycle than the last residue you went in with. And if you will try to get out any metals there, the next residue is even more complex. And so this whole circular economy thing where you can bring everything back into the loop, I can tell you why it is so complex in the metallurgical field. You can rank metals like gold is a very, very precious, and aluminum on the other side of the spectrum is very unprecious. And the more unprecious a metal is, the easier it oxidizes. Aluminum is never present as aluminum. It always has a very thin oxide layer on top. The problem is, if you now have aluminum and you want to recycle it, you always lose a little amount to the slag. Okay? And if you now have gold, for example, you can recycle it over and over again. Gold, you can just remelt and will never lose any gold. Aluminum is not the same thing. This is why it gets so complex. If you have a car and you separate all the different metals of the car and remelt them, you always will end up with some impurities in the unnoble or unprecious of the more precious metal in the unprecious metal, and you can't get it out. And this is why you always lose material in the recycling process, and this problem is unsolved. But I drifted off completely. I was saying that when I worked on recycling those sludges, I saw you always end up with some material that has no use in the end, and it can't go anywhere really. You know, like in the end, you have some slag, and it mostly goes to landfill all over the world. Actually, in Chile, because you're from Chile, Chile is the biggest copper producer in the world, you know, of course, because you worked in this industry. I just learned last week that Chile has 13 billion tons of tailings on pipes. Billion tons, not million tons.
Okay, well.
There's no use right now for this. So this is where our mining and circular industry, how it is really working in real time. And then I was like, there needs to be a way to valorize these materials. And then I came across an article where someone stored CO2 in a steel slag. I was like, oh, that's nice, because maybe you can use it to store CO2 in the end. If you can't use it anymore, and this slag is on pipes and unused, maybe at least you could store CO2 in there, so it doesn't harm the climate anymore. Then I looked into it, and it's a field that's been around since years already. And we then started, so I asked my boss at university, can I have a small research budget? And I got, I don't know, 10,000 euros or something like this. And I was allowed to employ a bachelor and a master student. It was the same guy who did his bachelor thesis and then master thesis. And we looked into carbonation of steel slag and just tried what already was already proven in the literature, that you can store CO2 in a steel slag. And this is what we tried. And then I was like, if I would ever found a company, I think this would be a really big lever, because nobody's doing it like on scale right now. With nobody, I mean very, very small amount of companies. There's a huge potential, and it's technologically very challenging. So I also wanted to do something which is very hard to do technologically. And then I thought I will work as a consultant now for a few years, build some contacts in the industry. I was thought about 3 years, but I didn't make it far. I just worked 6 months until I started to found a startup on the side. And then I tried to look for some motivated co-founders. Then we started.
So, okay, I am mind blown with the figures, I mean the numbers. It's a huge... I read somewhere that you are aiming to reduce the entire greenhouse gases in 10%. That you can store 10% of the CO2.
Yeah, this number also blew my mind, but I didn't come up with it. You know, as a researcher, you need to read a lot of literature all the time. And there are some journals that are very high ranked. You know, one of them is Science.
Yeah, sure.
So there was a Science article I just stumbled across, and they analyzed all the mineral wastes in the world and how much CO2 you could potentially store, and how much CO2 would be stored if those materials would be utilized in the building sector. You don't have to mine fresh materials for concrete, you know. So you carbonate the steel slag and use it as a replacement for fresh concrete. And this in the whole world sums up, and this is a conservative study. There's also one which gives double the amount of CO2 storage. Actually, I lied before, so it's a Nature paper, another science paper that is equally high ranked. If you store CO2 in all the mineral wastes in the world, you can store 400 million tons of CO2. And if you utilize these materials, you will save another around 3.6 billion tons, and this is 4 billion tons, and this is 10% of the global emissions. So we didn't come up with this number, but we used it a lot in our calculations. The potential is big, because if you look just in the steel sector, for every ton of steel you produce around 200 to 300 kilograms of blast furnace slag, and 150 to 300, it ranges on 150 to 300 of basic oxygen furnace slag. So both of them. And both of them can take up around 20% of CO2 if you do it the right way. So it's big numbers.
A lot. And well, the sequestra is a Spanish word, right?
Yes, this is.
which is to capture.
To kidnap, I was told.
Yeah, kidnap.
To capture.
Actually.
Like if you store CO2, or if you take CO2 and store it underground, or store it in a way so it doesn't harm the climate anymore, this term is considered as sequestration.
Sequestration.
So in German it's Sequestrierung, in English sequestration. So like sequestra sounds nice. So let's take this name. Then we secured the name, and that's
cool. So you have this like residual waste from the industry.
Yeah.
You are putting carbon on it, like fixed it to the material, and then you use that material like part of the construction.
So this is how it would end. This would work in the end. Yes, how we hope that it would work for many residues. We at Sequestra are not planning to do this ever. We are a technology developer. So we develop the technologies for steel plants to do this in the end.
Mm-hmm.
But we are not planning to take in big hypes of slag and carbonate it and sell the carbonated slag. In the end, it would look like this. We need to decide what is hard to abate and what is, I wouldn't say not hard to abate, but easier to compensate CO2. The hard to abate sector, there are a few industries which are not possible to decarbonize right now. It's cement, waste incineration, and the refractory industry. Refractory industry is if you take materials, mineral materials, and make bricks out of them that are used in furnaces and stuff like this. The refractory industry. In Austria, it's RHI Magnesita. It's a very big company. They are worldwide active. And the reason is, if you take cement and if you produce cement, 2/3 of the CO2 come from the input material. You have calcium carbonate, you calcine it, CO2 goes out, you have calcium oxide, and this has the binding properties of cement. So it doesn't matter what energy carrier you use, CO2 is emitted. The same is for waste incineration.
But there's also a potential for the cement industry using concrete as well to store, right?
Yeah, in the end, yes. But right now they are looking into this problem. I just attended, this number will blow your mind now, because it blew my mind big time. I already knew it before a little bit, but 2 months ago I was at a conference. It was by accident in Vienna. It was called the Global Cement Carbon Capture, Utilization and Storage Conference. Conference only dedicated to carbon capture and utilization in the cement sector. Mm-hmm. They calculated that for a medium-sized cement plant, that means like 1 million ton per year. It's not very big, it's not very small. Mm-hmm. 1 million ton clinker production per year. A carbon capture plant will cost 1 billion euros. This is more than a cement plant, you know?
Sure.
So now they are looking into this. The same is for waste incineration. You will never get rid of residual waste in a city, you know? Like everybody's talking about circular economy, but if you look what happens right now, people are still throwing out everything. And where does it go? A lot of it goes to recycling, good, but a lot of it goes into waste incineration plants. It's burned to generate electricity. In Austria and also in Germany, you're not allowed to landfill residual waste. In many other countries, put it into landfill still, but in Austria you need to put it into waste incineration, and this will come up in all countries in the world. All the developing countries are looking at this technology and like, this is perfect because we could get rid of our hypes
and we generate
some heat and electricity, but hard to abate. CO2 goes out, you know, like.
And look at just one step back.
Yes.
What are the technologies for carbon capture and utilization? What are the different technologies? And then also you can explain a bit about what is your technology.
Yes, and I'm just saying, you know, those are the industries that need to extract CO2 from the off-gas. They don't have any other possibility to get rid of their emissions. So now they need to capture CO2.
Okay.
There are different technologies, but they are also constantly evolving.
Please tell us about the storage process, how the carbon are getting stored in different...
Yeah, this is later, you know. First you need to capture it.
Yeah.
This is, we call it point source capture. Okay. Point source means there's one source where CO2 is emitted. And here you could install an amine scrubber, a cryogenic or a membrane technology. Another technology is direct air capture. You suck it out of the air. It's much more expensive right now, but it's also being developed. Then you have the CO2 present, okay? Let's say you have it now running out of the carbon capture plant in a liquefied form. So if the carbon capture plant and a liquefier. So what do you do then with it? I have to say, there are almost no plants in Europe that do this right now. In America, yes, but it's a different topic. They now go into the technological field of carbon capture of storage. Carbon capture and storage means storing CO2 underground in an old oil reservoir or old gas reservoir. The problem is right now there are around 400, if I'm not wrong, million tons of capacity of carbon capture installed in the world, or 450. But around 90% of this is enhanced oil recovery. So what they do is in America, it's very big. They take out the CO2 from the off-gas of a cement plant or of a coal-fired power plant, even worse. And then they liquefy it and pump it into oil reservoirs to squeeze out more oil. This is how this is. The climate technology, this is enhanced oil recovery technology.
So using CO2 to pump?
Yeah, this is a very major industrial, widely used process, enhanced oil recovery. So now we considered CO2 is somewhere in an off-gas or in the atmosphere. You extract it from this media, which is much easier in a point source, because in a cement plant off-gas, you have around 15% of CO2. In the atmosphere, you have 420 ppms. You can imagine how much more air you need to put through a process to get out the same amount of CO2. This is why it's so expensive, but in the end you have CO2. Now you could store it underground. In America, using it for bringing out more oil, unfortunately. In Europe, they're going more into underground storage where it reacts with formations underground and stays there forever. Solid, as a carbonate. This is what we do as well, but we do it above ground and store it in a waste material. So we use a steel slag. A steel slag contains chemical compounds that can take up CO2. They are calcium and magnesium, are the most important ones. If you have any material, also if you break down this building and take the building rubble, mill it finely, you can carbonate it. You can store CO2 in there. And this material is then carbonated, and then it could be used in a building application. And as soon as it is used in a building application, it's considered as carbon capture and utilization. So you don't, this is a bit misleading, but because you don't use the CO2, you use a material that contains the CO2, but it's considered as CO2 utilization. And now, a very important point. Until a few years ago, actually until last year in July, it's still very fresh, many major industrial players had the plan to build carbon capture plants to get rid of their emissions and sell the CO2 to the chemical industry to produce fuels or plastics. The problem is, what happens to a fuel? It gets burned and the CO2 is out again. The same is with plastics. You can produce a nice plastic structure, but then you recycle it maybe once, twice, 3 times, it degrades, and at a certain point it is burnt, and then it's also out again. So the EU brought out a law. The European Commission brought out a delegated act for the whole EU, which says every molecule of CO2 that's used in the building sector is utilization, and everything else is an emission. This is our biggest tailwind at Sequestra right now, because until now we had to compete with the chemical industry. You can take CO2 and transform it into a green fuel. You can still do it, but you have to pay the emissions fine for that, and this is not a good deal. So I know it's confusing to have the overall picture. There is a cement plant. You take the CO2 out of the off-gas in a few years. Right now, no cement plant has a carbon capture plant, but they're all planning to do it. And then you have waste materials. They can come from everywhere. It could be steel slag. It can be waste incineration ashes. Can be building rubble. It can be mining tailings from Chile. All of them can take more or less CO2, depends on the material, and then you use it in a brick, CO2 utilization. No fines paid anymore for this CO2.
No taxes for using it.
For using it?
Yeah.
No. Now, as soon as you use this material, the CO2 is considered permanently stored. because as a carbonate, it's not released at any times until you heat the material up to 1000 degrees, which does not happen before normal building material at any times once the building is built. If you break down a house and want to recycle this rubble, you mill it and use it as a recycling concrete, but you don't heat it up to 1000 degrees. So this carbonate stays a carbonate, and this is why it's considered permanent.
Wow.
Yeah.
Storage.
Thank you for explaining it, because decarbonization for a very long time was also a counting problem, that everything was happening at Excel. How to put put
what to
offset.
do with the CO2,
Yes.
It was still in there, but it was in the Excel sheet. It was going from here and there. But so just going back to the technology of sequestra.
Yes.
So how did it differ?
Now it gets into, we talked now about carbon capture, storage, and utilization.
Yeah.
Now we're only talking about the utilization part, and here about the technology that we follow is called mineralization or carbonation.
Yeah.
Carbonation or mineralization means mineral compound reacts to a carbonate. This is mineralization. Calcium oxide reacts to calcium carbonate. This occurs also in nature. If you have a mountain, if you have a volcano, it blows up, it brings out new material, carbonates very slowly, takes up CO2 from the atmosphere. We do this in a very enforced, very rapid way. It's called technological carbonation.
Okay.
And there are two major categories. There are direct and indirect carbonation, and we work in direct carbonation.
Okay.
So we take the material and carbonate the whole material directly. Indirect would be you leach out the carbonatable phase, like calcium oxide, and carbonate only this phase, and then you have pure calcium carbonate. This is not what we do. We take the whole slag material, for example, steel slag, carbonate the whole thing, and here you have three subcategories: wet, dry, and semi-dry, and we work in wet process carbonation. The reason is the kinetics are higher, so it reacts faster in a slurry. We mix the material with a slurry, with water to a slurry, and inject CO2, and it reacts with the water. CO2 reacts with the water to different pre-steps, and then to the carbonate. And this is what we do, and this differs to some of our competitors. They use other processes, or so many companies try to produce something that's it's called supplementary cementitious materials. So in the cement industry, you can use other materials other than cement as cement. But for this, you need binding properties of the material. We don't work in this field right now. Maybe in the future, we produce everything that's not an SCM right now. So because we have a wet process, so the hydraulic properties are already destroyed, our materials are very quickly carbonated, then used as a filler. And what we do different at Sequestra, we have one focus point. Sequestra is not a heavy industrial green tech company, just a heavy industrial green tech company. We are a hybrid between big data and heavy industrial green tech. And big data and AI is a big word.
Yeah.
But what we try to do is, if you take a steel slag and then you take a steel slag from another steel plant, they are different. So it's not, steel slag is not always the same. And if I take a tailing from Chile, it's also not the same. So I always need different process conditions. And the problem is, slag, what I said before, and industrial residue is very complex. An iron ore is super straightforward. You know, you have also some mineralogical phases, and it's a complex material, but the slag afterwards, most likely more complex. So it always differs, and it's very hard to tell why it's good for carbonation and why not. And we stopped this approach of looking into the material in a very nitty-gritty way and doing all this microscopic analytics. We just do rapid empirical testing. So we take the material and try to carbonate it and see if it does carbonation or not.
Yeah.
And this in a fully automated way in a small reactor. So we built a reactor which takes in a sample, does a test, puts out the sample, takes the next sample, does the next test, and can vary at process parameters. And this is completely automated. And with this, we want to generate a lot of data automatically and become, we call it the global leader in carbonation intelligence. We want to be the company that knows more about carbonation than anyone else, following a semi-blind rapid testing big data approach. So we just test the hell out of materials super fast and build up this big data. And then with models predict this material. In the end, it could go as far as, can I tell a steel plant to run their process a little bit different? So the slag looks a little bit different. And then I process it in this parameter set. So it goes into this building application in the most economic feasible way. It's super niche, of course. I know, I see your faces.
No,
Yeah, it's actually very interesting, but also it's challenging us.
Yeah, I'm sorry, but it's very, very niche. Where we are in a niche, I told you, like, there are categories down, and we are in the super niche of slurry carbonation. Here we are even more niche. But
with one technique, and then to test every material and to have a catalog like.
Yes, we follow approach. Like, if you send us a material as a customer and want to know how much CO2 can take my material up, we will anonymize your material. We don't care what it is. We run it through the same process every time, like a big blood testing lab. We just see what it does, this very rapidly. And here we are the first in the world. Nobody has ever done this, and nobody is doing it right now. So our engineering team, half of our engineering capacity are mechatronics engineers. So we are very deep in automatic reactors right now.
Was this your pitch to the investor as well, that they were like, I don't know what you're talking about, you're making a lot of sense, take the money and
This is a whole different topic, Right now I was just talking about the technical part, but this is what we do. We have two departments at Sequestra. One is called Sequestra Intelligence, where we want to become the leader of global carbonation intelligence. Yeah. And then we have Sequestra Industrial. Here we try to build reactors that would actually do this then out at the steel plant. So we use that our customer value proposition is as follows. You send us a sample of your material. We run it through our process. We can tell you this material can take up 60% of CO2.
Yeah.
And the process on industrial scale would cost X, Y, Z. We can set up this plant for X, Y, Z. And with the CO2 price rising to this level, you could earn blah, 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 as much money, and the material could go into this industry in this country. This is where we want to go in the next years, and then sell the plant. And such an industrial mineralization plant, this is then big projects. They cost a few dozen million euros, and this is then major industrial plant engineering. We are far away from this right now. Right now, we are very strong on this analytical side, starting to build the first reactors.
Right now, like you're processing a lot of different materials and gathering big.
Right now, actually, we don't process so many industrial materials. We calculated slag compositions ourselves and just produce them ourselves. So we work with synthetic slags where we can rule out disturbances and just train our technology. Is what we do right now.
Where are you getting those materials from?
So we are metallurgists. So we just calculated slag compositions. We bought the materials. We sent them to a partner. They did the melting. And then we sent them to another partner. They did the milling. And now we have, I don't know how many buckets of synthetic, very pure, very precise slag materials.
You said precisely it's not just for the heavy industry, but you're somewhere in between that it can be used not because of the intelligence what you're doing.
Yeah.
But primarily, it's still the hard to abate sector, right? Like the metal sector.
There is an urge for getting rid of CO2.
Yeah.
And with this new law that CO2 that's only stored in building materials, there's a big potential for the building sector to store CO2 in their building materials. So we talk mostly to companies that have huge quantities of waste materials that sell them to the building sector already. So for example, a very good case for us is the ready-mix concrete set. Ready-mix concrete are those trucks with the funnels on the back that go to the construction site, because this product is already wet, and we have a wet process. So you don't need to dry the slag before mixing it into the ready-mix concrete. So a good approach for us would be, you have a ready-mix concrete site, you bring some slag from the steel industry there, and for some CO2 from the cement industry, carbonate the slag and mix it into ready-mix concrete. And the business case in the end is that the building industry, this ready-mix concrete plant, this company can, the cement industry would pay in a few years, they're calculating like 2030, they're calculating 140 euros per ton of emission fines. So the cement industry would have to pay 140 euros for every ton. It's a lot of money for a cement because a typical cement plant emits 600,000-700,000 tons with 1 million ton of production. So you can calculate how much money this is. You would have to pay in fines. So the ready-mix concrete producer could say, I take your CO2, you extracted it from the off-gas, now it cost you like 40 euros per ton or 50, now you still have 90 that you are saving, so you're extracting it, and I take it and storing my material, and I will do this for 80 euros. It's a good deal, less than the fine, and this is the business case behind it. And for this, we built analytical and industrial technologies for this carbonation. And I think, I know I talk too much, right? So.
No, it's great. But these are the incentive, right? Like for the industry, why they should be doing it, and also the pressure on them.
It's not only the price. If you look at the emission trading system, first of all, the prices get high, and second, the emission certificates in total get less. At a certain point, you're not allowed to emit anything anymore. It doesn't matter how much money you have. In Europe, they drop every company out of the business that's not able to reduce their emissions. And like I said before, we have hard-to-abate industries, cement, refractory, and waste incineration. They are very, very hard hit. And then you have companies which have it also very hard, but a bit less hard. For example, the steel sector.
Yeah.
The steel sector can decarbonize with green electricity. The cement industry not. And this is the incentive to get rid of. This is a lot of CO2. And right now, this is also, many people don't really know it, but if we talk about carbon capture and storage, this is forbidden in Austria. You're not even allowed to do it. Right now, they are re-evaluating it, but the problem is we are very slow with everything. So if you would now build, so the cement plant needs to get rid of the CO2, otherwise they need to close the shop at some point. But if they would extract the CO2 right now, they have no way to go with it. So they don't invest into the plants right now. It's a very, very interesting and dynamic field right now. When I was at this conference, I was sitting in this room. There was like 100 people from all over the world, like scientists and CEOs from leading cement companies, and they were openly talking about, and nobody knows what to do right now. It was really interesting. It was like at the forefront of something big happening. Like we have this and this problems.
My question about the implementation challenge. Like that you're going to face. What do you think, like going forward? First, I want to know from you that the industry that you want to target, and you feel that they are going to be the first pilot or the first people that you would like to reach out to, and that you're already imagining working with, and then what are going to be the implementation challenge going forward?
So right now we are talking to a few different companies already. So what they want to do, and this is a very big business case for us for the next years. You don't always need to go, you have an idea and you need to implement it on this industrial scale. It doesn't work like this, A very big business case for us is finding out for companies if they have a case with their material or not. If you are a steel plant and you have 10 million tons of steel slag on a hype because you were supposed to landfill it, and now maybe you could bring it to the building sector, you need to find out if you can store CO2 or not, and how much the process would cost. And we try to find this out for companies. So sequestra intelligence is supposed to find out if a material has a potential or not. So this is where we move right now. And what the companies then want to know is how would it work on a pre-industrial scale? So they don't want to carbonate 10 million tons in 5 years. They want to just try it out with a few hundred kilos,
Exactly.
And right now we are having, fortunately, it's a very good situation right now, a few leads where we could maybe build those demonstration plants for companies. So they want to have those demonstrators on site and can carbonate some steel slag and try out different stuff. And there are not many plant companies right now that can build mineralization, or that are in this field. So we got approached by some very big companies. It's not right now, but it's maybe in 1 or 2 years we could be already setting up some of those. And this is how we move forward right now. And still, we are a startup, to build a plant. It's hard and big. So we see a very big case in this evaluating and securing IP. So
do you already have?
Yeah, we filed 3 patents already.
Okay.
Yeah.
And it's in the process right now.
One is already published. You can look it up if you want.
What is it about?
This is about fully automated data generation for carbonation and applying on industrial scale. So we patented this whole thing of generating the data in sequestra intelligence and applying it in sequestra industrial. So machine learning driven optimization of processes for carbonation. This is what we patented.
And that you got it as well.
Yeah, we got it. I mean, we filed it now. It's published, and now we need to enforce it in different countries. And we will try this, I don't know, now it's published. I think now we have 12 more months to enforce it in the end. Yeah.
I have a question regarding the European law that you mentioned. Do you think that it's going to have an impact in the prices of the construction material, like to be differentiation with others, like, hey, I can sell my product with carbon inside, so you can.
Yeah, like they are already doing this. If you look at the big cement producers, they talk about green cement. It's not green yet, but it's greener. And of course, I mean, I worked as a sustainability consultant before founding this startup, and I worked in a time when it was the biggest drive in sustainability consultancy that was ever there. It was 2 years ago. We went to companies and you could charge whatever you want. Everybody wanted to lower their emissions and print nice sustainability reports, and was the biggest topic ever. And back then, everybody was talking about building green and we need the greenest materials. Right now, this whole bubble burst a little bit, it got much less important. America moved way far away now from all these topics, and they have a big thing to say in the industry still. I mean, under Trump now, they're building new blast furnaces and opening new coal mines and stuff like this. So this whole drive, unfortunately, got a little bit away. But what we see is that it's still very important for the European industry, for the hard-to-abate and industrial sector, because they know it's a hard topic and you need to work on it for years and years and years. And still, yes, they are trying to charge more for greener cement, but it's not as important anymore. But it will, for sure, it always goes in loops. If it doesn't go in a loop right now, we are all done, I mean, we don't need to talk about this. It's already very late anyways. But I see that the whole sustainability thing got much less important. Like 2-3 years ago, everybody was buying a Lastenfahrrad. You know what this is? Those bikes where you can transport stuff.
Last mile
transport. Like it was everywhere. And don't throw away straws. And right now, people don't care. I don't know. It just got less. But still, the industrial sector is still very hard on decarbonization, because they know you can't just start and do it in 2 years.
I don't know if you're related with the construction, like the certification in the construction field.
Yeah.
Because they speak about zero carbon buildings or houses. So do you think that this can have an impact also in this certification?
Yeah, this has a big impact. Yeah, this is
avoided carbon or something.
Yeah. They did a lot of stuff, building with wood, using adding biochar to concrete, storing CO2 in materials. Zero carbon is nothing, like there's nothing zero carbon right now, unfortunately. But it is big, and yes, this is also, of course, an input. We want to get smarter in this field as well, and also have people who work just in this field, like building materials. Still, our niche is the carbonation, and there is importance to it, but this is such a, how should I say, the stuff that's connected to physics, and how to carbonate a material in an optimal way is the same in 10 years than it is now, But this regulation about what's green in the building sector is changing every year. So we observe it, but right now we are way too early anyways to talk in this industry. We are focusing on, if someone wants to carbonate materials, and a lot of people want to do this, how can you do it in the most efficient way? This is our
sector agnostic.
Yes.
Let's say
we are material agnostic. That's what I meant before. Yeah. If you send us, it must be mineral, but otherwise it doesn't store CO2. It must contain calcium and magnesium. As soon as you have a material lying around, you can send it to us and we will tell you what it can do in terms of CO2 uptake.
And also you're impacted around the globe. Like you're a startup based out of Austria, but then I'm sure you're getting leads out of all across.
Yeah, it was funny. You were laughing before about the conference I was, right? Carbon Capture and Utilization Conference. 2 weeks ago, I was at a conference. It was also in Vienna. By accident. Next year it's somewhere else, but by accident it was also in Vienna. It was called Global Slag. It's a conference. It's only about slags.
Only waste.
Only slags, not only waste. A slag is just as the metallurgical waste.
Okay.
So a slag is if you have a pyrometallurgical process. Pyrometallurgical means heating stuff up to around over 1,200 degrees and everything is liquid. You have the metal and then you have a mineral phase swimming on top of the metal, which contains everything that's not the metal.
Okay.
And this is a slag.
Impurities or...
Yeah, impurities. Like if you have an iron ore, you have iron and calcium, silicon, magnesium, aluminium, and all of this sums up in the slag. This is a slag. A slag looks like rock material. And this conference was only about slag. Global slag. There were like 250 people there. And I met a lot of people from all over the world, from Kazakhstan to South Africa to South Korea. And of course, we could work everywhere. But right now, this is 2 years down the road. Right now.
So just I could ask in Chile for some interested companies that.
Yeah, you can. Yeah.
Cool.
We can spend a lot of time on the technology. I figured. But I would like to also ask you a couple of other stuff because you're innovator and it's a hard tech, right? Like it's not cool. I mean, it takes time for the kind of work that you're doing. It's a scaling challenge. You already know for a while that it's like 3 years down the line that you have to do something. So you need a lot of patience. But what specific opportunities and challenges that you see for Austria and within the region for innovators, like for more green tech challenges, more difficult challenges, not cool stuff, but more in where you really need to innovate.
Yeah, this is a very good question. You know what? I invited you in 2 weeks we have a party.
Yeah.
You know why?
Tell us why.
You know why we do this? Because I realized that the climate tech bubble in Austria doesn't exist. There's no climate tech bubble because I'm talking about industrial climate tech bubble. There are a few companies, but clean technology development in startup ecosystem is not happening. I was part of the entrepreneurial leadership program of Austrian startups, which was very nice. It's a bootcamp program. Takes 1 year. Shout out to the guys there, guys and girls there. Very nice. Met some very good friends, but I was the only guy doing hardware. And then my co-founder was in a batch 1 year later. Only guy doing hardware. Not talking about green tech, just hardware. Everybody's doing software startups. Yeah. So the hard thing in Austria is finding anyone you can talk to about your startup to start from. Like there is no bubble, and we need to get better in this.
Also manufacturing, right? Like
manufacturing also. I know some hardware startups, but like people who had how we started in the workshop of my co-founder. With our own money, we buy the laptop, a scale, a tube, some pipes, and started carbonating lime from the workshop like where you use at the construction site from Baumax. We started to carbonate this in our workshop, and now we're trying to scale it into industry. If you want to talk to fellow founders, you don't find them in Austria. And this is a big pity. And what's the challenge? There's no ecosystem for it. We have a super good grant system in Austria. It's like one of the best in the world. If you want to get free money as a startup founder, you should come to Austria. There's a lot of grant money, but we have no infrastructure. For if you try to build a chemical reactor, have fun finding a workshop. It took us a year to find something, you know. In Sweden, they have green tech hubs where you have an office building on top, and in the ground floor you have a workshop where you can do whatever to scale up to a few hundred kilos of batch processing.
I know a EU-funded project in Sweden called Hybrid. They're also making they're making green material, green metals. I think they got 100 million fund from EU or something, and
Well, I don't know that, but yeah, Sweden is another thing. You know, in Austria, we have so many good engineers, but not a real lot of entrepreneurial drive. And if you would start, you would have a very hard time finding fellow founders. And this, coming back to the party, we now started to organize climate tech parties, where we bring people together, not just people who are already in the climate tech sector, but also, you know, some are engineers, but they don't have an entrepreneurial spirit, but maybe they meet someone there and they can co-found startup. And I was looking and waiting for someone to invite me to climate tech party, but I was done waiting. So we're organizing.
We will invite you. We already did it on 25th. So first we are going to have a conference and then we have a party.
That's perfect. Yeah. I'm very I appreciate it a lot that you are doing this also, because there needs to be done more, you know. Yes, not enough happening. So to be innovative in Austria, grants are perfect, but finding someone who can help you because they did the same thing 3 years earlier.
But just on that note, what startup challenges that you think in the heavy I mean,
I would say there's just a lot of opportunity.
Yeah.
Until now, it's always hard and a lot of work. And you need to maneuver fast, but you need to do this in every startup. But getting money was easier for us.
No, what I meant was that more innovative stuff in a green.
What could be?
Yeah, what could be potential?
There's so much. I mean, I'm coming from the metallurgical sector.
Yeah.
I could tell you a lot of stuff in the metallurgical sector right now.
Yeah,
for example, for example, if you look at steel production, steel emits around 7% of global CO2 emissions. Only steel.
Only steel.
Yeah. They always say if steel would be a country, it would be before India, you know, in CO2 emissions. That's what they always say. So it's a lot. A lot of people know this also, and they're like, we need to do something about steel production. Steel, 2 billion tons per year is production of steel. Half of it is in China. 2 billion tons per year. Aluminium, it's 70 million tons per year, so it's much, much, much less.
Yeah.
So steel divided by 30.
Okay.
It's aluminium, but 3% of the CO2 emissions. Only aluminium. Nobody knows that, you know. People like aluminium, it's nice, the foil, cool. Emits a hell lot of CO2. Completely untackled problem. If you produce aluminium, you produce a sludge. It's called red mud.
But you think it's also, like, for example, the most steel is produced by China.
Yeah.
And most aluminium, I'm not sure where.
China.
It's also
every metal is China except copper. Then Chile.
And do you think they're doing something about that? I mean, they're doing a lot about decarbonization as a whole with people.
You know, it's a lot in China, but also lots of somewhere else. But there is so much opportunity, and you could found a startup in every of those fields and do something, and you would find customers. In our field, mineralization, you know how many startups are there in Europe? We have a very comprehensive competition map, and we think there are not more than 20 all over Europe. You know, if you try to make a new app for food delivery, you have 20 competitors in every city. I'm just saying, you know, and so in talking about innovation, you know, one of our challenges, and this will be one of our new niches where we maybe move in. But if someone wants to found something, this is one of what I think. If you want to found a startup and want to have an idea and want to found which have the biggest impact is CO2 logistics. I think this will be a major case for if you need to remove CO2 from the off gas of a cement plant, where are you going to put it and how? This is major. You know, if you have a good model that can predict the optimal case, is it even worth it for this plant to extract CO2, or should you just shut down the plant because it's not worth it? CO2 logistics, this is a major case.
Now we would like to know about the challenges of scaling up a startup here in Austria and in Europe, especially in high tech, as you.
This is a good question.
Yeah, he talked about the ecosystem for a startup like yourself. So what are the unique challenges that you are facing?
I have to say, in our stage right now, it's good because there's a lot of grant money. In Austria, you have a really good grant situation. You can get big grants from the state. So up to 3 million euros is a very famous grant. It's called General Program of FFG, Basisprogramm. You can hand in sector agnostic, everything you want. They decide if they want to fund it, and you can get up to 3 million euros for your project budget for 2 or 3 years. And you can do a lot of stuff with grant money. For us as a high-tech startup, we will reach a point in the next years where we will need amounts of money that are not really there in Austria. And it's a good question. This is what I mean again, you know, like we don't have this big brother we can look up to and be like, how did you do it 3 years ago?
So you are building it on the way, kind of.
I have to say, right now, building an industrial tech startup, I think we are one of the first that ever did this out of Austria. So it's very hard to say right now, but I think we will do it with a good mix of investors' money and big European grants, and just try to, it's always important to gain a lot of traction, you know, to prove that someone in the end would buy it at the point where it can't sell anything yet. There's always this.
But do you consider maybe, for currently you're based out of Austria, that that there might come a time that you might have to base somewhere else? Yeah.
No, this could be the case. Right now, it's good in Austria. I have to say, we find good people here, engineers. The grant situation is really good. Also, recently, there's a big problem in Europe because companies get funded to a certain stage, then the money is not here anymore. Then some of the companies are not good enough, they die, and some of them are really good. And what happens? They get bought up by American investors and go over to the US. Now the EU wants to stop this because it happened a lot. Because at a certain point, you reach a level where no European fund can invest the sums American investors can invest. In Sweden, it's a bit different. So Sweden, UK, Munich is also a hub. They have big startups, but many of them just went to the US because they had the big money. And now the European Union wants to invest in startups, promising ones for them to stay. And they just published it a few weeks ago that they want to invest 70 billion euros in the next 2 or 3 years, the European Investment Bank. So we see right now a lot of opportunity, and maybe I'm talking too much right now, but I don't think that right now in the next 1 or 2 years we could completely fail, because what we do is niche and it's needed. I mean, people need, I know it's needed, and it's very research intensive. And the good thing is, if you build something like we do, the importance doesn't fade. You know, if you, let's say, you build something like Spotify. Spotify had a lot of competitors on its way, but all of them died. For us, even if we would now have 10 competitors, if you're selling, this is also one of my, what I always say, if you want to found something, heavy industrial green tech is a good field because you can never easily dominate a market completely. Because you want to build an industrial plant. Investors don't like to hear that. But you can't really dominate it. If you want to build an industrial plant, it consumes a lot of capacity, and you can't build industrial plants all over the world at the same time. Exactly. Spotify can do that. You can roll out the app on it's no problem. It's a software, you know. But for heavy industrial tech, it's hard to dominate a market, and this is a big opportunity for many different players. It levels it out a bit, and the market is gigantic anyways. Like for heavy industrial green tech.
Yeah, no, for sure. We think that you're going to make it.
Let's see. Thanks.
You were just telling us about the party that you're hosting, so that there could be more robust ecosystem. You know.
Yeah.
What do you think there should be more done in Austria, Vienna, as a you know, it's also the epicenter, because there's so many other regions which look forward to Vienna as a center for maybe startups going forward. So how can the ecosystem get better?
I don't really know. It's a hard question. It's a really hard question. What I found also, like talking about you, I don't know you really well. I mean, just a few weeks, but you already make something possible. You came from somewhere else and just started something, and you invite 100 people, and Leonora Kevesler is speaking at your event. There's no Austrian doing this. I don't know what's going on with the Austrian people, but most of them are just so lazy. It's fine, you know. It's a good life anyways. Many of my colleagues, good degrees, they work in the industry, it's just perfect. You know, I'm good money. Well, what should I do? Why should I found anything? You know, it's perfect.
Yeah.
You know what I mean? Like, I don't know how we can come up with this drive, but you just started it, and apparently it's working. You managed to invite a lot of senior people to your events. I don't know how you did it actually, because but it's really good. Many people tried this, but they failed big. I see that a lot of Austrian founders have drive, but I don't know. I never started this startup to earn a lot of money. I mean, on the way, maybe, but I always want to do something challenging and something in sustainability technologies. If you do this and follow something useful that could be big, it will get big at some point. Maybe not the first thing, but many of our founders in Austria want to found something to become rich. And this is not a very good incentive. You don't build a nice, flourishing ecosystem, I think, with too many founders who want to build the 20th dating app. Yeah. I have no idea how we can do it. And our startup ecosystem is good, but to bring more into this climate tech bubble.
Yeah, a party is a good idea.
Parties, yes. I think it's really a good idea.
We're going to support it.
Yeah, sure.
And yeah, just to maybe go into the future. How do you see the sequestra in 2030, for example?
Yeah, like in the best case scenario, we would be the leader in carbonation intelligence, you know, like having a big lab with fully automated machinery that's doing these tests. People are sending us samples, and we have the most brilliant engineers looking at big data models and be like, yeah, I don't know, we are able to predict this and that, and we can really look into the carbonation as it happens, and at the same time already building industrial plants. If sustainability doesn't die completely, which I hope it does not, but right now I have to be as realistic. I mean, did you hear what the German Chancellor just said? Yeah. It's just everything is going into the wrong direction a little bit. But I still think that there is a lot of potential and it will move back. It could be very good. It's hard to say. Right now, if I could go back and do I think I would found more or less the same thing. I would not right now advise anyone to go into something that just measures sustainability. I would urge everyone to go into a direction that really develops technologies that are used to reduce emissions. When the whole sustainability bubble started to go big, most startups were platforms that measured CO2 in something that we can track all your emissions, and many of them died right now because.
Yeah.
But really bringing down emissions technologically, I would go in this direction. I think every startup that goes into the direction still has a very bright future.
Just to in the advice space here for the community that is interested maybe to make a startup or some initiative, what would you advise in this regard? Like, with your experience?
not just in entrepreneurship, but also getting into the sector.
Yeah, exactly. In general, for energy transition.
Also, you're tackling mostly the industrial decarbonization challenge. Like, what kind of jobs you think, and how can people get into that?
Industrial decarbonization challenge. I think there are a lot of people already interested in sustainability. I would like to see more engineers being interested in sustainability.
Mm-hmm.
And this is what I tried to do with shift tanks. It's a very hard question. How would you do this? Yeah. I would just, at some point, I gave up motivating people that don't want to be motivated.
That's a good.
That's a good one.
Yeah, because I wasted a lot of time. But I would say, if you find people that have a certain spark, you can just help them. So what I do all the time is I hook up people. I meet someone, they tell me blah blah blah, I do this or that, and then 6 weeks later, I meet another one. I always remember what people do. I don't remember, like, when my mother tells me anything, I don't remember it. Like 2 minutes later, I forgot it. But if I meet someone at a conference and I met him 2 years ago, somewhere, I can still remember where this guy studied and what he did and blah, blah, blah. I remember all this professional stuff. So I always try to connect people, and I don't really have any advice, but if someone already has the spark, you can just tell them, hook them up with the right people, and you should just start, I meet a lot of people all the time, and 6 months later, they tell me the same shit again. Yeah, I'm also thinking about starting something. I'm like, what? Then do it.
Have you done? Yeah.
Yeah, well, I mean, just, there's this very nice saying, the book, The Almanac of Naval Ravikant, very good book. I recommend everyone to read it. It's maybe one of the...
I will check it out.
Yeah, it's really good. And he has, he quotes a lot of stuff, and one of it is, intentions don't matter, actions do. Like talking about stuff. A lot of people like to talk about what they would do.
Mm-hmm.
I don't know. There's no advice for people to interest them in sustainability, because many people tried it, and I think you need to utilize capacities people have for sustainability somehow. I don't know. It's a hard topic. Mm-hmm. I think I motivated already a lot of people in my life to do something in the direction of sustainability, but with many, I think it won't just won't happen. Like I had a friend who was working in sustainability and then just shifted and went to the defense industry. I was like, I don't know how this happened, but it just happened, and then. Mm-hmm. You can't motivate them. If you just motivate a few people,
that motivation.
Yeah, I heard saying that it's if the ideas will fly, it would be cloudy all day or something like that. Like,
yes, this is very.
It is to do things.
This is very true. Yeah, many people are just afraid to start, but some of them are not. Mm-hmm. And some of them, they just need some kick in the ass, and then they do something.
Yeah, we invite to the community to do and accomplish their dreams and just take the jump, like they take the leap and just go for it. That's
Hey, Lukas, do you have any last thoughts about like how people can engage more with Sequestra and learn about your mission?
Of course, we have a website which is mostly updated. On LinkedIn, we post a lot of stuff. I mean, we don't have we have something where you can sign up, but yeah, I think LinkedIn is the best thing right now to follow what we do, but we don't post a lot of insights all the time, you know. So most of our work just goes into developing. But if someone is out there who is like, I think I'm a very skilled engineer, it doesn't really matter what field. And we're really trying to hire a top-notch team. I think right until now we really did very well with a lot of very good people, and we also want to hire more very good people. So if someone is like, I would like to get to know this company, you can just reach out to me, and maybe at a certain point we can work together. Also, other startup founders that want to collaborate, we're always open for that.
Amazing. Yeah, this has been a very insightful interview. Thank you. I have a friend, Gabriel, in Chile, who is metallurgical, so he's going to eat. And we hope to have you again with some sequestra updates, and we wish you the best.
Thank you very much. It was very nice. Very nice. Thank you.
And for the community, thank you for watching this long interview until the end, and see you in the next episode. Ciao, ciao.